I'm in Blender 5.2 and I'm using Midi2Blender to connect my USB MIDI controller to geometry nodes. In this sound-reactive project, I can control the megaphone sides, close the honing, open the honing, and then, of course, I can explore some night vibes. You know, the usual stuff you want to do with your real-time animations. The way it works is actually very simple. From here, you can create a mesh object made of vertices. This object is connected to your MIDI controller and receives the MIDI signals through attributes. Once you press start, you should already be able to see the different incoming MIDI signals. Let's take a look at the data in the spreadsheet. This is note number 60 at index 60, and here we can see the velocity value for that note. Here I can choose which attributes I'm interested in. These path buttons on my controller are also seen as MIDI nodes, but they are mapped to a different MIDI channel, channel 10. These knobs work like sliders and send MIDI CC values. CC values are mapped after the nodes, so for example, CC number 70, index number 198. Most of the times you don't need every single node pad and control on your MIDI controller. Here you can map only the controls you actually want to use with a simple learning system. When you're done, press stop learning and you have your custom mapping. Let's look at a few practical examples. Start with this fader. It's made of two objects, the fader itself and the bass. I want to move the fader along the y-axis. And I want to control it using this MIDI CC knob, so index number 198. I use a sample index node on my MIDI mesh object, set the index number, and sample the MIDI velocity named attribute. Then I use combine XYZ on the y-axis. Let's see if it works. Okay, it works, but I need to adjust the range. The velocity value goes from 0 to 1, and these are the map range values I'm using. Let's move to this button. Its material is connected to this named attribute. By increasing this value, I can turn the light on. I want to control it using this note number 60. This time I only care whether the value is different from 0, so I use a compare node to set not equal to 0. And there we go. Of course, it's on only while I'm holding the node. If I want to turn it into an on-off toggle, I've prepared this node group, which you can find in the project. Here I select my MIDI mesh object and the index I want to use. Midi2Blender switch contains simulations internally, so it works while our animation is playing. And here's my on-off toggle button. The counter output gives me an integer value that lets me move from one element to the next, like moving through a list. This means, for example, that I can map multiple functions to the same button. Now let's look at something a little different. Go back to our fader, but this time I want to control it in a different way. The factor maker gives me a value from 0 to 1 while the animation is playing, starting from a Boolean trigger. This means I can trigger animations driven by a factor. By default, the first button press makes the factor go from 0 to 1. Pressing it again reverses the animation. This parameter controls the animation speed. This is what I use to create these animations very easily. Here you will find a series of presets that can be useful for manipulating the factor. Loop, back and hold starts the loop on the first press and stops it on the second. But instead of stopping immediately, it returns to 0 from its current position. I slow the animation down so you can see it more clearly. The same thing happens with ping pong, back and hold. You can easily manipulate the factor using float curve node, but there is a very basic smooth parameter here for quick adjustments. There are also a couple of very simple node groups to start visualizing your MIDI inputs. Midi2Blender 0.1 joins a series of tools I'm developing for real-time interaction in Blender. Have a look around my channel. There are already lots of possibilities and more are on the way. That's it for now. Have fun experimenting with Midi2Blender. Bye.